Why does lanthanum hydroxide behave so differently from lutetium hydroxide, even though both are +3 lanthanide hydroxides? Very important question. Let us try to understand the concept behind this. Now here, let's consider lanthanum. We know that. So first let's assume La+3 ion. So this is La+3 ion, and let's try to visualize this. So this is a big La+3 ion, okay? So just try to imagine the size is so large, okay? Here is OH minus sitting, okay? So OH minus are sitting over here. Now, these OH minus are going to leave La+3 easily, okay? They are going to leave easily. Why? Because La3+, the charge remains the same across the period. So when you go from lanthanum to lutetium, the +3 charge is going to remain the same, correct? But the radius, the ionic radius is going to become small. The ionic radius will shrink as you go from La to Lu. Alright, so La+3 has a bigger size, and since it has a bigger size, it will not pull the OH minus ion towards itself. Okay, it's not going to hold the OH minus ion towards itself, and because of that, the release of OH minus ions is going to be really easy. Okay, so the release of OH minus is easy. The release of OH minus is easy, and because of that, lanthanum hydroxide behaves as a base, or you can say it is the most basic in nature because it releases OH minus ions. Now, since it is most basic in nature, or you can say king of bases, I can say it will be least acidic in nature, most basic and least acidic. I hope that's clear. Now let's move to the rule says larger size. Okay, larger size means more ionic character. Okay, if the size is large. So as in case of La3+, we have seen the size is large, therefore it will be more ionic in nature. So more ionic bond, and more ionic bond means stronger base. More ionic bond means stronger base. Very important, correct? So mostly basic. So now when you move across 4F series, there is lanthanide contraction, and because of lanthanide contraction, ions will shrink. All right. So small ions will hold on to OH minus tightly. Okay. So let's see lutetium now quickly. Let's see lutetium. Lutetium Lu3+, on the other hand, is a small size anion. So this is a small size anion, and now if I draw lutetium Lu3+ is a small size anion. Now if I draw OH minus over here, what's going to happen? Yes, as you can see, the size is very small. It is going to hold, it's going to pull the OH minus because the size is large. Because the size is small, so it will pull. Yes, it will hold on to the OH minus very tightly. All right, and therefore this bond will become covalent in nature. Therefore this bond is covalent. All right, and therefore I can say this is least acidic in nature. When you put this in water, okay, what will happen? It will not release OH minus ions. All right, it is not going to release OH minus ions. Lutetium hydroxide will be most acidic in nature and least basic. All right, so I hope that clears up the topic. Okay, so then according to our rule, what we had written earlier, if the size is small, okay, so let's write down the next rule. Let's write down the next rule. So smaller size will be more covalent in nature, will be more covalent bond, and more covalent bond means weak base. More covalent bond means weak base. All right, so you can screenshot this. All right, so therefore I can say lanthanum hydroxide will be most basic in 4F series. All right, so if you want this topic to be explained with the help of props, please comment in the comment section. You can comment 3D, and I will post my next video with the help of physical props. All right, thank you.